We've all been there, right? You see an AI do something absolutely brilliant, like write a beautiful poem or solve some crazy complex problem, and then, in the next breath, it makes a mistake so simple you can't help but laugh. It's this mix of incredible power and, let's be honest, frustrating blind spots that really defines AI today. But what if we could actually get inside its head, find out why it makes those mistakes, and steer it back on track? Well, that's exactly what a new breakthrough is letting scientists do.
So here's our roadmap for today. We're going to dive deep into the mind of a machine. First, we'll look at where things go wrong. Then, we'll explore the early attempts to get control. After that, we hit the big one, the aha moment that lets us unscramble an AI's brain. We'll see how scientists find the exact thought they want to change, check out the amazing results, and finally talk about what this all means for us.
Okay, so imagine you have the smartest GPS in the world. It's a genius, but every now and then it just gets obsessed with a wrong turn and it will confidently, happily lead you miles and miles in the wrong direction. Well, that's pretty much what happens inside even the most advanced AI models. They get lost in their own thoughts.
And here is a perfect example of what I'm talking about. We've got an AI trying to solve a math problem. It starts off great, totally on the right path, but then it just completely misses a key detail. The problem asked for the length, but the AI decides it's going to find the area instead. And just like that, it charges ahead, totally confident, locked on to a completely wrong answer.
This right here is the big question. What if, at that exact moment it starts to go off course, we could intervene? What if we could just reach in, grab the metaphorical steering wheel, and guide the AI's reasoning back onto the right highway?
You know, people have been trying to get a handle on AI behavior for a while. The first few attempts were kind of like being a backseat driver. There were two main approaches. One was just telling it what to do, called prompting, and the other was a bit more direct, called activation steering. But as you'll see, neither one was precise enough to really guide a single thought.
So, on one hand, you have prompting. This is basically just typing instructions at the AI. Like, hey, maybe check your work. But half the time, the AI just ignores you. It's not very reliable. On the other hand, you've got activation steering, which is a bit more sci-fi. It's trying to directly tweak the AI's internal brain activity. But the old way of doing this was clumsy. Imagine you're trying to conduct a whole symphony, but all you have is one giant volume knob for the entire orchestra. You can turn everything up or everything down, but you can't tell just the violins to play softer. You have no fine-grained control. Right, so if you want to conduct the orchestra properly, you need to be able to talk to each section individually. And for an AI, that means we have to look inside its hidden state, which is basically its internal thought process. The only problem? It's a total mess in there. A giant, jumbled, tangled mess. And this mess has a name: concept entanglement. I know, it's a bit of a mouthful, but the idea is actually pretty straightforward. It's when one single little neuron or component inside the AI's brain is trying to represent a bunch of different ideas all at once. For instance, the same signal might mean both, I should backtrack and fix that mistake, and I should verify my answer. So if you try to boost that signal to encourage backtracking, you accidentally boost verifying too, and the result is just unpredictable chaos.
Think of it like this. You're looking at a giant, tangled knot of electrical wires. You know one of them controls the light you want to turn on, but if you pull on it, 5 other wires move with it, and you end up turning on the fan and the toaster too. It's just too messy to control any one thing precisely. So the big question was, how do you untangle that knot?
And this is the hero of our story. A tool called a Sparse Autoencoder, or SAE for short. The best way to think about it is like a special decoder ring for the AI's brain. It takes that tangled, messy hidden state where all these concepts are squished together, and it unfolds them into this huge, organized space. It's like taking a crumpled up piece of paper and spreading it out flat on a table. All of a sudden, you can see all the individual words clearly. The SAE does that for concepts, which scientists call features. So, the SAE takes our tangled knot of wires and neatly organizes everything into a clean, beautiful switchboard. Now, instead of that jumbled mess, we have one specific wire, one switch, for each individual concept. One for backtracking, another for verifying, and so on. Finally, we have the individual controls we've been looking for. Okay, but this creates a brand new problem. It's a good problem to have, but it's still a problem. We've gone from having a single useless volume knob to a massive switchboard with tens of thousands of switches. How in the world do you find the one specific switch that controls the exact thought you want to influence? And I'm not exaggerating the scale of this challenge. The SAE can spit out over 30,000 potential concepts or features. Trying to test every single one of those would take forever. It's just not practical. You need a much smarter way to find that one needle in a giant haystack. And that's exactly what the researchers built, this really elegant two-step system. The first part, called recall, is like a quick and dirty filter. It uses keywords to find any feature that might be related to what they're looking for. This one simple step is incredibly powerful. It knocks out over 99% of the options. Then, for the second stage, rank, they take that much smaller, manageable list and put them through a bunch of tough tests to find the single best performing feature. And at the end of that whole process, what you're left with is this: one winning feature. Out of tens of thousands of possibilities, they can pinpoint the single, perfect switch on that giant board to control one specific way of thinking. It's pretty incredible.
So the theory is cool, the method is super clever, but here's the moment of truth. Does it actually work? Let's take a look at the data and see what happened. And the numbers, well, they speak for themselves. That simple prompting method, it barely moves the needle, comes in at 0.39 on control effectiveness. The old way of doing activation steering, better for sure, at 0.62. But look at the new SAE-Steering method. It clocks in at 0.76. That is a massive jump in our ability to control what the AI is thinking. It's a huge leap forward.
But honestly, this number might be even more exciting. This isn't just about control for the sake of it. When they used this technique to correct an AI that had already made a mistake and given a wrong answer, they saw a 7% absolute improvement in its accuracy. Think about that. They are actively making the AI smarter and more accurate, fixing its errors as they happen. And this example just drives the point home perfectly. On the left, an older method gets the AI to say the right words, like another. But if you look closely, it's just going through the exact same flawed thinking. It's superficial. Now look at the right. With SAE-Steering, the AI genuinely shifts its whole mental approach. It starts thinking about the problem in a completely new way. It's not just changing the words, it's changing the thought itself.
So let's pull back from the technical details for a second. Why does any of this matter to you and me? Well, because this is all about the future of how we interact with AI. It's about building systems that we can actually understand. And more importantly, systems we can actually trust.
So, if you only take away a few things today, let it be these. First, we now have a powerful new tool to precisely control an AI's internal reasoning. Second, we can use this to fix an AI's mistakes after they've already happened, making them more accurate. And finally, this is a huge step towards building AI that is more reliable, more understandable, and ultimately more trustworthy, especially as we start giving them more and more important jobs to do.
So for the first time, we really have a reliable steering wheel for an AI's mind. We can guide its thoughts. But this incredible new power also raises an even bigger, more profound question. Now that we can steer, who gets to decide the destination? Who draws the map?